All right, so this video is about the cofunction identities, and cofunctions are the trig functions that are related by basically by the word co. So sine and cosine, tangent and cotangent, secant and cosecant. And in the cofunction word, the co stands for complementary. And you might remember from geometry or from class, complementary angles. Complementary angles are two angles that sum to 90 degrees, or if we're in radians, pi over 2. And you can see from any one of these relationships, like if we take the co-functions involving tangent, so cotangent and tangent, if I take the two angles that I'm plugging into these two things and add them together, they get pi over 2 radians, so those are complementary angles. So if I take any trig function and plug in one angle, and I take its cofunction and plug in its complementary angle, then those two expressions are going to be identical. So, quick examples. Whoa, I don't know what happened there. So some examples would be like if I took cosine of 32, well, that's going to be the same thing as sine of 90 minus 32, which is what, 58. So, you know, that's there are other values that also work, but sine 58 is one of them. If I had tangent of, let's say, negative pi over 4, then one cotangent value that is definitely the same is going to be pi over 2 minus negative pi over 4. Right? Because if I add those together, I get pi over 2. Those are complementary angles. So let's see, what's that? That's 2 pi over 4. That's 3 pi over 4. If I took, what's left? Let's do secant. So if I had secant of, let's say, 102 degrees, well, then I know that's got to be the same as its cofunction, and I'd plug in its complementary angle, which would be negative 12 degrees. Okay, so there are some quick examples of how that comes in handy. And let's take a look at how we actually can show that these things are the case. So what I want to do is I want to start with sine pi over 2 minus theta equals cos theta and prove that. Now we already know what the sine graph looks like. So I'm going to start with y equals sine theta. And I want to turn that into y equals sine pi over 2 minus theta. So I want to show that, that this bottom one is really cosine theta. Really the same as cos theta. Okay, so in order to get there, let's use our transformations. So I'm going to use that general point method. A sine A is the point that would be on this graph. And then down here, if I call pi over 2 minus theta A, then negative theta is going to be A minus pi over 2. And then if I take the negative of both sides, I get positive pi over 2 minus A. So then the point that this turns into is pi over 2 minus A, comma, and then sine, and this is just A now. So to get from A to pi over 2 minus A, then I need to do a horizontal reflection, and then I'm going to shift to the right. So horizontal shift, right by pi over 2, and then I don't do anything vertically. So let's actually graph sine theta. So here's what sine theta looks like. Let me plot the important points on this thing. So here we go. Oop. A little messy, but you get the idea. Okay, and what I want to do is so this is originally this graph, and we're going to apply these transformations to it, and then hopefully and so we'll get this graph, and it should look like cos theta. So a horizontal reflection, I've got these little computer tricks here. So I'm going to reflect this horizontally, and then I'm going to shift it pi over 2 to the right. So this point at 0, 0 is going to end up over here at pi over 2. Oh, I flipped the entire picture. Let me undo that for a second. Okay, let me just select the curve instead of the entire axes too. Okay, so I'm going to flip this. Excuse me. And then I'm going to move that origin point to pi over 2. And when I do that, I end up with the cosine, excuse me, cosine graph. So graphically, we've proven that sine of pi over 2 minus theta equals cos theta. Okay. Here, let's do this. So if I take the cosine graph here, I just complete the graph. So if I take the cosine graph and apply the same exact transformations, now you might be able to tell here. Let me shrink this down. So if I were to take y equals cosine theta, which is the graph that I now have, and apply the same transformations to get y equals cosine pi over 2 minus theta, then hopefully I get the sine graph back. Now the only thing that I'm doing in this general point, it's a cosine theta, or cosine a. I'm going to apply the same exact transformations in order to get pi over 2 minus a cosine a here. So it's still horizontal reflection, then horizontal shift right, pi over 2 units, just like up here. So let's reflect it horizontally. Rotate, flip horizontal, which is the same graph anyway. And then this has to move pi over 2 to the right. And now we got the sine graph back because it starts here and goes up and then comes back down. So this guy is the same thing as sine theta. So we've proven the first two. Let's do the tan theta one. Okay, so tan theta has an asymptote here and an asymptote here. And let's see, pi over 4 is 1, 0, negative 1 here. This is a pretty skewed graph here. So it does something like this. Right, like that. And we're going to apply the same exact transformations to get this. So it's going to be a horizontal reflection and then a shift pi over 2 to the right. So let's do that. So let's flip horizontally and then shift it pi over 2 to the right. And this graph that we ended up with is the cotan graph. So you could do the same thing with the cotan graph and you'll get the tan graph instead. So now we've essentially taken a look at these three, and then this one you can kind of do on your own if you wanted to. And then we'll do the secant one just so you have it. So, whoops, highlighted too much there. Here, I'll just erase that. Okay, so the secant graph is the cosine kind of inverted graph. So that one has an asymptote here, and here, and then it goes up like this. And there's another asymptote here, and this one goes down this way. And another asymptote here. This one also goes down. And then kind of like this if we complete our picture. So so this is the graph of y equals secant x, or secant theta. We're going to do the horizontal reflection and then the pi over 2 to the right. So let's do that. So rotate horizontally, which is the same graph anyway, and then pi over 2 to the right. And now we've got the graph of cosecant instead of secant. And you could do the same thing to get secant back if you wanted to. So that's these last two here. Okay, so I hope that helps some. And there are a bunch of other videos talking about how to get the other trig functions too, or the trig identity, the basic trig identities as well. Okay, hope that helps.